Historically, there was timber, metals to some extent. What all those materials have in common is that they start out as a block or a piece of stock or a sheet. It's basically the same in all directions. So you can take a sheet of metal, and whether you orient it one way or another, it has the same properties. It has a uniform thickness. Timber obviously has a grain, but again, it basically starts out as a block. And you take away material to basically reveal the part. That process has some limitations as far as how much you can vary the properties of a piece over its topography. With advanced composite materials, the difference is that you make the material at the same time as you make the part. So you start out with two separate components, which is a fiber and a resin, and you basically combine them together in the best possible way, and you can stagger them and orient them differently and blend different materials and get the properties that you want exactly. And that gives you the freedom to whittle it away to almost nothing where the loads are diffused, and build it up to make it really tough where you might have a fastener or a stress concentration. One way to think about it, which isn't too glamorous, is like reinforced concrete, where you have the concrete itself, which is brittle in tension but is quite good at resisting compression, and then you have steel inside it that takes care of the tension. So with carbon fiber and Kevlar and Dyneema and all various iterations of advanced composites, the fibers are good at doing one job, which is taking tension, and the resin matrix, which is a thermoplastic, holds it all in column and bonds it together and stops it from buckling. So when you combine the two, you get a material that's really good at two different jobs, and is essentially made bespoke for the part.